Intermittency is a big problem with renewables, and actually today's electricity price perversely is driven by the gas price, not the intermittency of wind and solar. So around 20 years ago, I was involved in the project sat under EDF, who are predominantly a nuclear generator, and they have a very fixed and flat curve of generation. We took a Caribbean island and we put smart meters on this island with the ability to control people's air conditioning, which is effectively an air source heat pump. By having a smart meter, controlling the demand side of it, we were able to cut our generation costs by 60% by simply doing that. Now, the similar technology can be used here. If I go back to an old program on TV, probably in the 80s, 90s, Tomorrow's World, they talked about this new technology, which was a smart meter, which could control the compressor in your fridge or your freezer. Here we are, some 30 years later. The smart meters that went in were purely about remotely monitoring your electricity or gas bill. We should actually be able to use these as much smarter equipment. Again, looking at Sweden, they tend to have a 16 amp three-phase supply to each of their properties, and that's not sufficient to run a heat pump, a cooker, a washing machine, a dishwasher, a freezer, a fridge. So they monitor the load on that supply, or the heat pump monitors the load, and it holds itself off for 10 minutes, 20 minutes, whatever's required. And that's not going to affect the heating or hot water in a property. So today, at current electricity and gas prices, you need a heat pump with a coefficient of performance of something like 3.8, which is easily achievable for your running cost or your heating cost to be the same as they are on gas. If you swap the levies over, suddenly gas goes up by 50% and electricity comes down by 40%. Suddenly it's cheaper to run a ground source heat pump and clients will flock towards it. It is all about how much it costs to run at the end of the day to the person on the street. I think by taking away the cost of the ground collector, using government investment and private money to build communal ground collectors, that halves the cost of a ground source heat pump installation. If we look to manufacturers, if they can build a package box with far more included in it, then there's less on-site installation work, and it very much becomes a box installation, as gas boilers were. Traditionally, gas boilers were a gas boiler and a hot water cylinder. Then it became a combi gas boiler, which is one item in a box. You connect gas up to it, you connect cold water, hot water out, heating flow and return. If we can make a ground source heat pump operate in the same way, so rather than gas, you're connecting up your communal ground collector from the road, then you've got your heating flow and return, hot water, your cold feed and hot water out, and electricity, very similar to a gas boiler, becomes a very similar way of installing it and a very similar mentality to doing that.